so moving on to section 1.5 of the textbook, Dive into Systems, all about systems programming. Here we're going to learn about arrays and strings. If you're coming from a Python background, the nearest thing to a C array would be a Python list. They are significantly different. So to get started with the differences, let's just look at how you declare a C array. So we would say int a bracket 3. What this says is that the name of my array is A. It will store integers and have size 3, meaning it stores 3 integers. Now, already you can tell that this is pretty different from how things work in Python, because in Python, you don't need to consistently make every element of a list the same type, but in C, in an array, you have to have everything the same type. That is static, and in a sense, you kind of can't change your mind later, or at least it's not easy to change your mind later. Also, you have to choose the capacity of the array. Initially, it's not filled with anything, but you have to decide right up front how many integers, in some sense, you think you're going to need. So you have to declare that it's going to have capacity 3. In advance. And again, that's a static thing. You cannot easily change your mind later. This is all different from how things work in Python, where you can just append elements to a list, and behind the scenes, it takes care of all of this like dynamic resizing for you and so on. Now, it's going to be important that we understand some of the hardware activity that happens when you declare an array, and it kind of explains why things are this way. So let's make kind of a diagram to represent the physical hard drive memory of your computer when it runs this program. Now, I'm just going to make up a memory address number, right? A memory address, right? If you have a physical hard drive, it's got a bunch of places where data is stored, and those places get corresponding numbers, basically. That's called the memory address. I'm going to make up a memory address 12. That is very likely unrealistic. Memory addresses tend to be much larger than that. But just to keep things simple, I'm just going to make up a random memory address, call it 12, pretend as if that could really be the memory address. But in any case, so A, we're just going to imagine, is located at address 12. And that's the address. And over here, we're going to draw what is stored at that address. Because we declared the length of the array 3, then we're going to get 3 memory addresses, and they all, when you're doing an array, it always gives them to you in sequence. So if 12 was the address of the first element, 13 is going to be the address of the second element, and 14 is going to be the address of the third element. And that is all of the memory that the computer reserves for this array, because you said that you only need 3 integers. Now, not only does it reserve 3 spaces, but it makes sure that the size of the space is the size needed to accommodate an integer. So that's true for all 3 of these. So this is why C wants you to declare the type so that it knows how much space you need, and it also wants you to say how many elements you're going to need so that it can reserve that much space on your hard drive. Python does stuff kind of like this behind the scenes without you knowing it. But because, it doesn't use a consistent type, then it has to actually eat up a certain amount of extra hard drive space, accommodating all of the different possibilities that might go there. So, long story short, the fact that lists in Python can take any kind of type makes it a little bit wasteful of hard drive space. And when it does an append function, that can cause it to need to spend some time, right? Because it needs, when you make this list, it's going to reserve a certain amount of hardware space. But when you exceed that hardware space, Python is going to do it for you without you knowing, but you exceed the space that was allocated for it. What it basically has to do is create a new space somewhere else, whatever, I'm going to make up, again, random numbers, but it's going to, make up, a new sequence of addresses and copy the old information over to the new address. But this time with extra space, so that you have all the data that you used to have, but now you have extra space. And basically the point is Python does all this for you without you knowing it, but because these things are not decided in advance, then it can lead to slowdowns, right? Like doing all of this, creating extra space and copying everything over, it takes up time and memory space that possibly, if you wanted to control it in a more careful way, you might be able to not use up so much space and time on your computer. So that's why in C you have this extra control over exactly how these things are managed, so that if there was a way for you to design things cleverly to avoid the need for these kinds of things, you could do it, or maybe you can't avoid it. But whatever, the point is just that Python uses up more space and runs a little bit slower on average because it's doing all of these things without you even knowing about it. So anyway, the point is that in C, though, things are very sparse, things are very bare. Now, one thing, by the way, is that because things are so sparse and bare, if you have a Python list, you can simply call len of the list, right? So if lst is some variable that stores a list and you call len lst, this will give you the length of the list. That's like a built-in function. It's basically due to like the list class having associated functions. But that doesn't exist in C. Again, right? C is very sparse, C is very bare. All you get with C in an array is carved out space with memory addresses. It doesn't give you anything more than that. Everything else you have to build yourself. So we'll see demonstrations of that in a minute. So let's look here at this Python example. So this is a main function. We declare an empty list, and then we start filling, right, appending to the empty list, which is not something that you can do in C, right? This append function grows the size or the capacity of your list. That is, and it's like doing it dynamically. It's, resizing things for you. You don't have to control that. That is not something that happens in C. Okay. Here we see coordinate assignment, so you tell me the index 3 of the list, and I'm going to put the value 100 into that index. That actually goes almost exactly the same way in C. So that's actually a strong overlap between the two. Here we print the length of the list. Again, right, the length is something that you cannot simply call on in C, but in Python you can. And then here we print all of the values in the list, and that is going to go somewhat similar in C. And then we call the main function. Okay. So now let's look at the same sort of idea, but this time in C. Okay, here, we're always making a main function, int main. We declare int I. We also declare size as an int and simultaneously initialize it to the value 0. And this is how we're going to keep track of the size of the array. Rather than there being some function that does it for us, we have to manually make this variable that's going to increase as we add things into the array and decrease as we take things out. So we next declare our integer array. It's an integer array and it has space for 10 integers. Here, what we seem to be doing is filling every coordinate with the value of I, right? So index 0 has value 0, index 1 has value 1, and so on. And every time we add to the array, we increment the size so that basically the size is faithfully tracking how much stuff is in the array. We can do coordinate assignment just like in Python. We can print the size variable that we have been manually, independently maintaining as the elements in the array are added or removed. And then we do a for loop and we print all the elements. That's very similar to Python. And then we return the signal for success. And that's how you do basically arrays in C. Yep, you can do coordinate assignment. There's zero indexing, right? Python is zero indexed. C is also zero indexed. Oh, what else do we talk about? Do we need to talk about here? And you can do more than just integer arrays, of course. This is an integer array for 10 integers. This is a char array of 20 chars. Another difference that might not be apparent in Python and C of the program is how Python lists and C arrays stored in memory. C dictates the array layout in memory, whereas Python hides how lists are implemented for programmers. C, individual array elements are allocated in consecutive locations. We've already seen that. So, okay, yeah, I think we've basically covered everything. It's possible to not use up all of the available capacity. There's just no requirement for it, right? The capacity that you initially declare is like a maximum on how much you'll store. But if you only fill up some portions of it, right, there's no nothing prevents you from doing that. Now, one thing that is very important is that if you were to, have a list containing 7 elements in Python, and you try to access coordinate 7 or coordinate 10 or anything beyond the, last valid index of the list, you would get an index out of bounds error, or index error, I guess. In C, that does not happen. In C, it gives you no errors, it gives you no warnings. So if you have an array of length 10 and you assign into coordinate 10 the value 100, it will do that, right? Like it will, in some sense kind of pretend as if the array had a coordinate number 10. But we know that like if its initial address was 12 and then it goes up to address if we have 10 elements, then the last address would be 22. And there is a value here, right? And right, all of this is carved out for the array. But index 10 refers to like, in a sense, like the 11th element, which is not supposed to be there at like address 23. And you assign 100 to that, it's going to actually assign the value 100, right? It's going to fill this thing. But what that very well might really be doing is writing over some other existing code that is being used for the program and cause all kinds of really catastrophic errors. And a lot of times it's just so hard to even know where the error is coming from, because you don't even, like, a lot of times when you do these index out of bounds errors, you're doing it completely accidentally. You just aren't even aware that that at some part of your program is trying to access an index that isn't available or valid. But C will not give you a warning and it will not give you an error. It'll just do it, and then you're going to get some kind of weird behavior that you can't explain. So you have to be very careful about that, right? You have to design, basically, in all kinds of places, checking whether the indices are within the expected bounds. Okay, let's now talk about arrays and functions. So we saw in the previous video that when you pass a value to a function, like here, it is passed by value. We really emphasized the point, but this time we're going to pass in an array. Kind of roughly what pass by value meant was that the values get copied over and assigned to the parameters of the function. Is that what happens when you pass in an array. You would think, well, if everything is passed by value, then it should be. Well, it turns out that actually the answer is no. And in this one instance, as far as I know, this is the only instance in C where actually it is passed by reference. That when you pass an array into a function call, what actually gets passed over is the address of the array, not the values in the array. So in a certain sort of sense, right, like I think the way the book explains it is they say that the value of the array is the address, so that, that way you can still say that it's passed by value. But honestly, that sounds like you're kind of, in some way sort of avoiding recognizing that, what is being passed is the reference, right? So in this way, I would just say that it is passed by reference for this one data type. Now, kind of as we discussed, what are the consequences of something being passed by reference? It is that if you make an edit to the object, if you reassign or in some way manipulate the object inside the function, you will still see the effect of that outside the function. So, for instance, if you look at, let me just clean some of this off. If you look at this, the passed in array is R, ARR. We never try to reassign the values in the array, so you would never know that it's passed by reference or passed by value. You can't tell the difference because we never make any changes to the array inside the function. By the way, since we're here, let's also mention that almost always when you're designing a function that takes in an array argument, you also pass in the size parameter because, presumably you're keeping track of the size, as we've already talked about, manually, you've built it yourself. And so at any point when you pass the array over, you almost always need to know what the size is, like for instance, so that you can do a for loop like this. So you almost always pass the size into a function if you're passing in an array. Anyway, okay. But here, again, we're not manipulating the array, so you wouldn't even know the difference between passed by value or passed by reference. Let's look at another example. I guess this example doesn't illustrate that, so maybe we want to skip down below. Yeah, this example. So what we now have is, again, we're going to pass in, right? We're designing a function which takes in an integer array, and we pass in the size. And then what we say is that so long as the size of the array is greater than 3, basically just saying so long as it has an index 3, then we are going to reassign the value at index 3 to the value 8. Now also, it's worth noting that here we are going to assign the value of size to 2. Now, because this is passed by reference, the change that is made here inside the function is then going to show up after the function has been called, right? Outside the context of the function. That is characteristic of pass by reference functions. But this, because this is passed by value, because it's just an integer, it's not an array, this change, you are not going to be able to see its effect outside the function. Because there the value was copied rather than indicating this location in memory and blah blah blah. So anyway, now let's see these things get used. So okay, we're going to make our int main function. We're going to declare an integer array holding 5 integers at most. We're going to just declare this variable n equal to 5, presumably just keeping track of the size of the array, or the capacity of the array, and this integer I not yet initialized. Okay, we do a for loop using I and fill the array with the values 0, 1, 2, 3, 4. We go ahead and print the array at index 3, which should just be the value 3. That's what they say here. We also print the value of n, which is 5. And then we pass these into the test function that we were just discussing. Again, because the test, because this is passed by reference, the edit that the function does to the array, you're going to see show up even on this line after the function has finished executing. So what does this do? We are going to print out the array at index 3, and now that value has changed to 8 because of what happened inside the function. We're seeing here, we're seeing here a consequence of the pass by reference behavior because we're outside the function call and still seeing the effect of the change to the array. But here, it's still 5, right? Even though there was this reassignment of size to the number 2, because integers are passed by value, a change made inside the function does not show up outside the function. So that's very right. That causes very subtle errors. I think that one time when I was early in learning computer science, I made some mistake. I didn't understand these things, and this basic thing was like responsible for me spending like 24 hours trying to find the bug. The bugs that these things cause are so subtle and hard to detect that you really want to keep them in mind. So anyway, here we have a bit of a diagram explaining basically the same stuff. So what's going on is this is the execution stack. Initially, there's just the call to main. Main creates an array, fills it with the value 0, 1, 2, 3 to begin with, 4, and it makes the value of n 5. But then main makes the call to test. Test has this variable a, but because it is passed by reference, then a refers to exactly the same physical piece of memory that array does. And so when test edits a, manipulates a to now contain the value 8 in address 3, that change still shows up in main. Test reassigns the value of size to 2, but that change, because that part is passed by value, does not show up in main. Function test are highlighted, change it does not change. Yeah, okay, so that's it. That's the point. Okay, let's move on to talking about strings. So if you're coming from a Python background, then strings, it turns out, are actually these pretty big, robust objects that you might not even be aware of because Python does so much for you in the background. But when you type double quote AB close double quote, maybe you think that's just a sequence of letters, but in fact in Python, that's actually a whole class. And you can tell that it's a class because it actually has what, you may or may not have, had an opportunity to use these dot methods, but right on the string, you can call a dot method like capitalize. And what that does is it, evaluates to the new string AB. But the point is that if something has a dot method, that's, especially in Python, that's an indication that it's a whole class, right? It's not just a bare object, right? Like if you think about like the number 1, you couldn't call one dot, I don't know, some method, whatever you want to think of it, toString or something, whatever. But the point is that this cannot be done because 1 is a basic object. It's not even a class. It's one of the most bare things in Python. And, and these bare simple objects don't have dot methods, but big, rich, robust objects that are whole classes, they support dot methods. Strings in Python support these dot methods, various of them, you can go look them up. But the point is that in Python, a string is a big, robust, complicated object that is mostly hidden from you. Well, in C, nothing's hidden. It's just that strings are very minimal sparse objects. Basically, a string is not that different from simply a char array. So let's say that we have char bracket 3. We'll call it A. And let's say that we assign a at 0 is char a, and a at 1 is char b, and a at 2, now this is important, is the null character. /0 is the null character, and so this is basically the one way that a string in C is not just the same thing as an array of chars, because an array of chars can be filled with any chars. But if something is to be a string in C, it must terminate with the null char. That's basically a signal that both this thing is a string and that is where the string ends. Notice, by the way, that we could have done this differently. We could just say a bracket 0 is a bracket 1 is the null char, and this is legitimate, and this is basically a string of length 1, right? By the way, right, so what this kind of means also, let's remark, is that if you want 2 letters in your string, you need to make space for 3 chars, because you need space for that null terminator at the end. But as I think we've kind of seen previously, in general, when dealing with arrays, there's no requirement or obligation that you fill the array all the way. So you could make space for 3 chars, but then only fill up 2. Why you would want to do that is, maybe up to you in whatever context you're in. But anyway, the point is that whenever you are using a char array to represent a string, basically the one thing that makes it a string is that the last char in your in your array, like after the last letter of the string, you must have the null character. And so that is, in a way, that's kind of all there is to strings in C, because that's just what a string is in C. I guess there is more to say. So there is the string library, right? You can include the string library, and that will give you a certain amount of, like functions that you are able to use to, to manipulate strings in common ways. So for instance, by using that string library, you can get the length of a string by calling on its strlen function. What else here should we talk about? So this is printing a string, right? %s is string. Here's a string. %d is a decimal. Here's a decimal, namely the len, which presumably is the integer length. Okay. This is a nice function that allows you to string copy one string into another variable. So here they were both declared as strings with capacity 10. We only used up 2 letters and the null character. And since there is space available, certainly, right, if str2 had size only 2, then you could not do this right here, but because the space is appropriate, then you are free to copy string 1 over to string 2. What else? Right. And this is a way to copy one string into another, which possibly is worth knowing that, if you want to write your actual string, one way to write your actual string to get the letters into the string is to write it one line at a time. But of course, that's so much syntax and that's so tedious. So this is a bit of a shortcut. That's one way that you can put the string hello into a variable without having to write it in a sense, in that way, one character at a time. Okay, anyway. What else should we talk about here? So we've got strlen, we've talked about strcpy. Note that C's string library expects the call to pass in a character array that has enough capacity for the function to perform its job. We already talked about that. Everything has to end in a null character. Up to you, the C program, to ensure that you pass valid strings into the library functions. To undefined behavior could cause it to crash. Yep, so I think we're somewhat familiar with all of these things. Strcpy can be an unsafe function. It assumes that its destination is large enough to store the entire string, which may not always be the case, right? So here, right, the destination of this, where was it? This strcpy, the destination was str2. Str2 had enough space, as we already remarked on. But if what would happen if it didn't have enough space? It's just going to write anyway, right? Again, C really takes the guardrails off of things and lets you really mess things up. So you do have to be very careful. And so anyway, what it's getting at is that strcpy is an unsafe function. It gives you the freedom to just freely edit data that maybe in some sense wasn't supposed to be edited, I guess. Anyway, or at least not in that way. So we chose to show strcpy now to simplify the introduction of strings, but we illustrate safer alternatives in a later section. So, okay, I guess we're done with that.